So our first panelist, not only is he an energetic, fabulous person here in America, but throughout the Middle East. Jonathan Trent received his PhD in biological oceanography at the Scripps Institution of Oceanography. He worked at the Boyer Center for Molecular Medicine at Yale Medical School, studying cell adaptation mechanisms to high temperature. I have no idea what that means, but you can tell us. At Argonne National Lab, he developed biotechnology and bioremediation, researching using organisms from extreme environments. In '98, he moved to NASA Ames Research Center to be part of the newly established Astrobiology Institute. Shortly after coming to NASA, he formed the Protein Nanotechnology Research Group and became an adjunct professor at UC Santa Cruz in the Department of Biomolecular Engineering. In '07, with support from Google, thank you Google, he shifted his research to focus on global research into energy and the environment at NASA. And in 2008, he's also an inventor. He invented Omega, which stands for Offshore Membrane Enclosures for Growing Algae. He raised, he's a fundraiser too, $10.8 million from NASA and the California Energy Commission to do a lot of amazing things that he'll tell you about. He is now leading the Omega Global Initiative to establish the first Omega demonstration project in a protected bay somewhere in the world. In addition to work at NASA and UC Santa Cruz, Jonathan is an adjunct professor at Tokyo University for Agriculture and Technology in Japan, and a lifetime fellow of the California Academy of Science. He has been identified as one of the PE 100. Does anybody know what that is? The Purpose Economy 100. And you can check it out on TED Global Talk. So let's give one of our three distinguished panelists, Mr. Jonathan Trent, a big round of applause. And next we're going to move into John. Yes. I would love to introduce our next speaker. It's changing by the minute. Jacqueline Chan is a public health professional with experience in public health epidemiology, grassroots mobilization, and community-driven development for improved health outcomes. She received her Master of Public Health in Global Epidemiology. Epidemic. I got it. Epidemiology. Can you tell I'm from Hollywood and I'm not a scientist? My mother's a nurse. I should know this. Epidemiology. 1, 2, 3. Everybody say it. Epidemiology. Yes. Epidemiology. Of course. This is what happens when they hand it to you. But I'm doing a good job. From where she partnered with Millennium Water Alliance Ethiopia to evaluate drinking water interventions and investigate barriers to equitable water access. That's near and dear to my heart after seeing what I saw in Lagos. Prior to her graduate studies, she led the Student Community Services Department at Cal Poly State University. Which one? There's
San
two.
Luis Obispo.
San Luis Obispo. See, it doesn't even say it. And my son goes to Cal Poly Pomona, so I know there's two. And with the Global Learning Program, which integrated global service projects with classroom curriculum. She was the conference director at the 6th and 7th annual Change the Status Quo conference, which empowered attendees with tangible tools for social change. We're going to get some tangible tools today. She's currently a founding member of the California Health Corps and has supported projects with Engineers Without Borders, USA, and Emory University's Center for Global Safe Water. Let's give our second panelist, Jacqueline Chan, a big round of applause. We're going to be a little bit up here on the panel, somewhere around here. Last but not least, we have the fabulous Symphony of Wellness, John Madison. He's Assistant Medical Director and Chief Medical Information Officer at Kaiser Permanente. Proud to say that all of my siblings were born there. My mother's been a nurse there forever. Southern California and is dedicated to advancing health information technology at Kaiser and to advancing health policy at both state and federal levels. He designed and implemented his first EHR in 1984 and has designed or implemented 6 additional EHRs since then.
What's an EHR?
You know what? If I would have just had this hand to me right now, I would have researched it. What's an EHR?
Electronic health record.
Electronic health records, which, as we all know, is so important because we can get in and out to the doctors a lot faster. He chairs both regional and national IT investment portfolios for Kaiser. His team led the first and largest deployment of Kaiser Permanente Health Connect, the largest private health record deployment in the nation. He continues to lead scores of innovation projects throughout Kaiser Permanente, ranging from mobile healthcare apps, social analytics and interventions, telemedicine, big data analytics, and behavioral economics of change. He is currently launching a project to transform how complex data sets, including genomic, microbiomics, exposomics, socialomics, and phenomics, can be transformed through visualization into intuitive representations. He's really smart. Now, it wouldn't be anything if we didn't have any goal setting, so he put it right in his bio that his primary goal is to harvest the exponential growth of knowledge about health and use it to help individuals participate more directly in improving their own health. In other words, we're taking control of our own health, and he knows how to make everybody in the world do it better. He's using individuals to participate more directly in that, and with resilience at the same time engage their communities, that would be us today, in broader initiatives around health promotion for all members of the community. So let's give our third panelist, John Madison of Kaiser Permanente, a very big round of applause.
Well, so I was working in academia for many, many years. In fact, doing some really cool and exciting research that was very much ivory tower types of things in nanotechnology. We were using self-assembly and molecular recognition to build data storage devices. And in 2007, I received this support from Google to do a project I called Sustainable Energy for Spaceship Earth. And it was just a lark. I wanted to try to understand the situation that we were in, to try to work on a way to move beyond where we are right now. And I want to present to you the solutions that we came up with for you as a group, for us as a group, and you as individuals to contemplate whether or not we're really moving in the right direction. In order to do that, I want to start with a presentation that was prepared for Rio Plus 20. And hopefully we can
This is the story of how one species changed a planet.
Can you turn the lights
The latest chapter of our story begins in England 250 years ago. Fueled by coal, then oil, several brilliant inventions appeared. They ignited the Industrial Revolution, which spread like wildfire through Europe, North America, Japan, then elsewhere. The great railways, then cars and highways, connected people across the globe. Medical discoveries saved millions of lives. New artificial fertilizers meant we could feed more people. Population rose rapidly. But this was nothing compared with what was to come. The 1950s marked the beginning of the Great Acceleration. Globalization, marketing, tourism, and huge investments helped fuel enormous growth. People swarmed to cities, which became even more powerful engines of creativity. In a single lifetime, the well-being of millions has improved beyond measure. Health, wealth, security, longevity, never have so many had so much. Yet 1 billion are malnourished. In a single lifetime, we have grown into a phenomenal global force. We move more sediment and rock annually than all natural processes, such as erosion and rivers. We manage 3/4 of all land outside the ice sheets. Greenhouse gas levels this high have not been seen for over 1 million years. Temperatures are increasing. We have made a hole in the ozone layer. We are losing biodiversity. Many of the world's deltas are sinking due to damming, mining, and other causes. Sea level is rising. Ocean acidification is a real threat. We are altering Earth's natural cycles. We have entered the Anthropocene, a new geological epoch dominated by humanity. This relentless pressure on our planet risks unprecedented destabilization. But our creativity, energy, and industry offer hope. We have shaped our past. We are shaping our present. We can shape our future. You and I are part of this story. We are the first generation to realize this new responsibility. As the population grows to 9 billion, we must find a safe operating space for humanity, for the sake of future generations. Welcome to the Anthropocene.
So this to me was a very big eye-opener. The generation that we're now seeing, which is really a very unique situation on the planet, is looking at a population or sharing this globe right now with about 7.1 billion people. The transition that we need to talk about is real and it has to happen. But it's always infuriating to me to just sort of speculate about how horrible the situation is. The reality is that when the woman in that presentation of the Anthropocene says that it's our creativity, energy, and industry that are going to make a difference, and that we have shaped our past, we are shaping our future, but the real question is, can we shape our future? I mean, we are shaping our present, but can we shape our future? Because the important issue is what's going to happen when the current generation is surrounded by 9 billion people by the year 2050 or 2060. In fact, the problem is worse than that, because if you look at the distribution of people as indicated by these red dots, you realize that we in the United States represent less than 5% of the world's population. In India, there's 17% of the world's population, and about 1.2 billion people, and 18% of the world's population in China, at 1.3, nearly 1.4 billion people. What this means is that in the United States, a person dies every 12.6 seconds, and one is born every 7 seconds. Whereas in China, a person is dying every 3.4 seconds and is born every 1.7 seconds. The populations are growing still on the planet, although there are places it's slowing down. The United States is sparsely distributed with people. I mean, you see these red dots in Los Angeles and San Francisco and in New York. But the distribution of people is nothing compared to what you see in terms of the densities in India. The real issue is, if you look at the energy use in the world as indicated by this night sky composite from NASA, you realize that the United States is using nearly 25% of the world's resources. That is, less than 5% of the world's population using 25% of the world's resources. What this translates into is if India lived like we live in the United States, India alone would use 85% of the world's resources, and China would use 90% of the world's resources. That is to say, if we export our lifestyle, which, by the way, we're doing a really good job at doing, using the media and the internet, if we exported our lifestyle to China and India, it would take nearly 2 planet Earths to support this lifestyle. But the reality of what's happening right now, which is incredibly daunting on the one hand, or fearful on the one hand, and incredibly exciting on the other, has all been run by oil. We've been harvesting energy that's been put in place millions and millions of years ago, and it, during the course of the history of the evolution of energy, has driven this phenomenal success. Not only success in terms of population, but also success in terms of technology. And the oil industry has evolved and become incredibly sophisticated, and it's based on the fact that some hundreds of millions of years ago, the shallow seas that covered much of the Earth's surface produced huge amounts of tiny organisms, mostly microalgae, that settled to the bottom and were buried under sediments to produce the oil that we use today. And the organisms that were responsible for most of this, 90% of this, are tiny organisms shown here in comparison to a human hair. And these organisms, the good news is, are still alive today. And when we think about trying to produce a replacement for fossil energy, biodiesel can be produced by soybean, sunflower, canola, jatropha, palm oil, or these same microalgae that produced this oil that we're now harvesting as fossil oil. The difference is that in gallons per acre per year, soybean produces 50, and microalgae can produce up to 5,000 gallons. So now when we're talking about how are we going to do a sustainable source of energy, are we going to grow biofuels on land, which they now do in Europe? It will take thousands and thousands of acres, and we have to feed a population that's growing. So the question is, could we use microalgae that are the source of oil, is the question that I posed now 6 years ago. And the answer is that, well, we could potentially, if we could grow microalgae without using water, without using fertilizer, and without using land. That is, without competing with agriculture. Well, the good news is that we can grow these microalgae on sewage. So our coastal cities can be the basis, with all of the wastewater that we're pumping offshore, could be the basis for doing this. And the notion that we came up with was, think about the protected bays that exist, like San Francisco Bay, where if you look at the distribution of people in San Francisco and what we do with our wastewater, here's Treasure Island. For us, the treasure on Treasure Island was the wastewater treatment plant, because that wastewater treatment plant, just as the city of San Francisco, pumps its wastewater offshore. That is to say, the wastewater is released offshore. And what this means is that if we look at our wastewater treatment plants in coastal cities, they're pumping wastewater offshore. And this is what led to the project that we just heard about, that I mentioned, called Omega Offshore Membrane Enclosures for Growing Algae. And this was meant to be a completely practical solution. Unfortunately, the model of what this looks like needs to be supported by other infrastructure, like solar panels and wave energy and wind energy. And in fact, when you do the calculations, the practical calculations that Sanji was telling us about this morning, the practical reality is that only if we integrate this system as well with aquaculture can we create a sustainable system. Now, the concept of Omega was put together 6 years ago as sort of an inspiration. Maybe this is how we can do it. It was initially based on some of NASA's concepts for what are called life support systems.
I am so sorry to interrupt, but we're going to move on.
Okay, I've got 2 more slides.
2 more slides, and then I just want to let you all know, all of these amazing speakers, they could speak for hours on their topic, but you're going to get a chance to interact with them in the next portion. So we'll finish our 2 more slides, and we want to give an equal now, I'm hearing 10 minutes to our next 2.
Okay. So we built the system on the $10.8 million that I raised, partly from the California Energy Commission and partly from NASA. We actually built it, harvested algae, and looked at the biofuel production. And not only looked at the biofuel production, but looked at how well we could treat wastewater. And now the issue is, can we build this at the scale that it needs to be built? Can we actually make this work? And can we do it to make biofuels, solar energy or alternative fuels, food from the aquaculture, and at the same time improve the environmental conditions, and looking at water as one of the byproducts. So let me end with these final 2 slides. The generation that we now have, that we now are experiencing, has gone from a sort of primitive oil energy-based culture to a fairly sophisticated one. The question is whether or not during the process we're going to reach the year 2060, will we be able to go to some more sustainable system. The Omega Global Initiative, which I hope to talk to you about, is to identify the potential for Omega sites around the world, disseminate information about the system, do it as an open source development, ultimately with the concept that failure is not an option. And I look forward to the interaction.
Let's keep